Welcome everyone. In this video lecture, we will solve GATE 2025 EC question which is based on the local maxima and local minima determination from a function fx. Okay, so the question is consider the function fx which is defined as fx equals to twice x cube minus 3x square minus 12x plus 1. So we have to identify which one of the following statements is or are correct. Okay, the option number one, fx has no global maxima. Option B, fx has no global minima. Option C, x equals to minus 1 is a local minima point. And option D, x equals to 2 is a local maxima point. So this one is a question. So this question is very simple. First, we have to write to solve such problem, first we have to write the function which is given. That is our fx equals to twice x cube minus 3x square minus 12x plus 1. Okay, then after we have to differentiate the function. So if we differentiate, it should be 6 square, okay, minus 6x minus 12. Okay, then after next step we have to do fx equals to 0. Okay, so if we do the fx equals to 0, what we will write? 6x square minus 6x minus 12 equals to 0. Then take 6 common. X square minus x minus 2 equals to 0. X square minus x minus 2. So in general we can write it x square minus x minus 2 equals to 0. Then one more line we can write. So x square minus x minus 2. So can we write like this? Minus 2x plus x minus 2 equals to 0. Then we have to find the root. So what we will write? X common, x minus 2 plus 1. Okay, I am doing each and every step. So it should be x plus 1, x minus 2 equals to 0. So the critical point we can say x is either minus 1 or 2. Okay, so the very first thing for local maxima and minima, if the function is given, first differentiate it. Okay, first do the differentiation, then we have to find f dash x. Okay, then we have to just make it 0, and finally we will get the 2 point, that is our critical point. Is it okay? X equals to minus 1 2. Okay, now then after, here I am writing, then after what we have to do, we have to find the value of f double dash x. Okay, so for f double dash x, so just think about this. F dash x is given, so f double dash x is 12x minus 6. Okay, then you just find f double dash x at x equals to say minus 1. At x equals to minus 1, the value will be 12 minus 1 minus 6. So it should be minus 12 minus 6, that is our minus 18, which is what? Less than 0. So if f double dash x is less than 0, so it gives local maxima point at x equals to minus 1. Is it okay? Now again we have to find the value of f dash x at x equals to 2. So 12 into 2 minus 6. 24 minus 6 is our how much? 24 minus 6 is nothing but simply 80, which is greater than 0. So this point will be our local minima at x equals to 2. Okay, so at x equals to minus 1, it is giving local maxima. Okay, so this statement is wrong. X equals to minus 1 is a local minima point. No, it is wrong. So this is not our correct option. X equals to 2 is a local maxima point. No, it is x equals to 2. We are getting the local minima. So these two are not the correct option. Okay, so and also if we draw the graph, okay, so suppose this point is our what, x equals to minus 1 and x equals to 2. Even if we go for the what, at x equals to minus 1, at x equals to minus 1, suppose at x equals to minus 1, what point of, what value we are getting, okay, suppose for f equals to minus 1, what we will get, 2 minus 1 cube minus 3 minus 1 square minus 12 minus 1 plus 1. Okay, so it should be minus 2 minus 3 plus 12 plus 1. So 3 to 5, 5, then it minus 4, it 8. This value will be 8.8 something. Okay, and f of 2, if we find f of 2, means 2 into 2 to power 3 minus 3 into 2 square minus 12 into 2 plus 1, means 16 minus 12 minus 24 plus 1. Okay, so see, 16 plus 1, 17 minus 36. Okay, then how much? It should be 19 minus 19. Okay, so this point have some minimum point. Okay, so and above this the slope will be increasing, so the graph is somehow, okay, this graph will be somehow like this, but there is no, means boundary is given, so it must have some local maxima and minima. So we can say this one, this having the value, these two are the wrong option as we already calculated. So the fx has a no global maxima, but it must have some maxima point which we can't say. So fx has no global maxima now. Okay, so this one is the, but the function must have the global maxima. So fx is no global maxima and fx is no global minima is now the correct answer. Okay, so these two are the correct answer, a and b. A and b is the correct answer, you can say a and b is the correct answer. Okay, even the slope, even the slope you can find, means how, why I have made one more thing that I want to share. Means 2 points we are getting. So minus 1 and 2. And if we think above 2, the slope will be positive, and in between it is negative, and in between this one will be positive. So first up to minus 1, okay, slope is positive. So that's why it is going like this. Slope is positive. Then after 1 to minus 2, slope is going to decrease. Then at x equal to, after 2 point, the slope is going to increase. So like this. So this point is our x equals to minus 1 is our local maxima, and x equals to 2 is our local minima. Okay, but here it is wrong. The wrong statement, x equals to is a local maxima point, which is wrong. It is a minima point, and x equals to minus 1 is a local maxima point, but it is written minima point. So both the options are, and fx is no global maxima. So here there is no global maxima. Okay, and fx is no global minimum. Okay, so this option number A and B are the true one. So this is the way. Okay, and one more theory. Suppose those who are new for this topic. So first thing we have to find f dash x equals to 0. Then we have to find the critical point, the roots. Okay. Then after we have to find f double dash x. Okay. Then you have to find f double dash c. If it is greater than 0, local minima. If f double dash c is less than 0, local maximum. So this one is also the important theory, we can say. So this is all about this video lecture. So thank you for watching this video. Thank you.